everyone, a warm welcome to each one of you. Welcome to our number system journey. Yes, so today we are seeing that numbers are placed exactly where they belong. So let's explore it together. Let's start with the basic one, our old number line. Yes, what is it? A horizontal line, a straight line with equal intervals. Center is usually 0. Before 0, the negative numbers are there. To the right of 0, the positive numbers are there. Yes? Exciting. Let's just quickly recall what we have understood in the previous two sessions. Natural numbers we have done, whole numbers we have done, rational numbers we have done, irrational numbers we have done. Yes, so what are natural numbers? 1, 2, 3, 4. What are whole numbers? Adding 0 to the mix. What are integers? Bring in the negative numbers, and rational numbers are your fractions, isn't it? So let's just start how to represent rational numbers on the number line. So just quickly dive into its definition first. Ready? Okay. Rational numbers are the numbers that can be presented in P by Q form. But along with the condition, my dear learners, what is the condition? That denominator should not be 0. Yes, examples are 1 by 2, minus 3 by 4. Yes, rational numbers include negative fractions too. Yes, so minus 3 by 4 is a rational number. 5 by 1, even 0 is a rational number because it can be written in the P by Q form. 0 by 1, and 1 is not our 0. Condition is also satisfied. So positive, negative fractions and integers are there. Even they include decimals too. Remember, if it ends or repeats, gives us rational. So today's lecture, what we are going to do will be locating rational numbers on a number line, and we will convert to same denominators if all the rational numbers are having different denominators. So our first thing will be to make the denominators equal, and then we will divide the unit segment accordingly. Let's stepwise understand it. I just insist you, my dear students, just take out your notebooks, a pencil, a clean page. Please draw a number line from 0 to 1. We are diving into the representation of rational numbers. Yes, so we have to go practically. Just open your notebooks quickly and just mark 0 to either side and 1 here. That's your number line. Only mark 0 and 1. Now I'll tell you what instructions you are going to follow here. So first question is, we are going to represent 1 by 10 on the number line. Yes, 1 by 10. What kind of fraction is it? It's a proper fraction. It's a proper way to represent. Yes, we can take one part out of 10. Easy. So always remember, all proper fractions lie between 0 and 1. You don't have to divide every time and observe that whether which numbers it is lying in between. No, just observe it is proper fraction. So it would be lying between 0 and 1 always. Like 1 by 10. 1 by 10 is our proper fraction. Yes, because numerator is less than the denominator. I hope you are pretty much clear about it. Now, divide the segment between 0 and 1 to 10 parts. Why into 10 parts? What do you think about it? Because the denominator is 10. Yes, whatever the denominator is we are having, we have to divide our segment into that much parts. Okay, so you just divide the number line into 10 parts And the 10th part would be our 1. Why? Let's see. First part is 1 by 10. Second part is 2 by 10. Third part is 3 by 10. Fourth part is 4 by 10. Fifth part is 5 by 10. 6 by 10. 7 by 10. 8 by 10. 9 by 10. And lastly, 10 by 10. That gives you 1. That's why the last step, last division is your 1 always. Understood? Now, where is 1 by 10 is located? Firstly, 1 by 10 is located over here. 1 by 10 is located over here. But if I ask you to locate 10 by 10, 10 by 10 is what? Your 1. What if I say locate 9 by 10? That would be your 9 by 10. Easy, right? Surely. Now, it's time to show 1 by 4 on the number line. Let's draw the number line again between 0 and 1. Why between 0 and 1? Because again, it is a proper fraction. Just mark 0 here and 1 to the other end. Done? How many parts we are going to divide it into? We have to look the denominator. Denominator is 4. Just divide this segment into 4 parts. And fourth part would be 1 only. So in between there are 3 parts only because fourth part is itself 1. So that would be 1 by 4. That would be 2 by 4. After simplification, 2 by 4 is 1 by 2. 2 ones are 2, 2 twos are 4. And the third part is 3 by 4. And the fourth part is 4 by 4. That is 1. Means whole quantity is taken. 4 parts are taken out of 4 parts. So we have shown 1 by 4 on the number line. Now it's your task to represent 3 by 4. Just do it your way. What is the first step you are going to do? Ma'am, we are going to draw a number line first. Then you have to mark the 0 and the 1 to its both ends. Done? How many parts you are going to divide it into? Let's recall. What is the denominator? 4. So 4 parts we have to divide it into. How? 1, 2, 3. Fourth one is 1. So now you have to locate 3 by 4. Just tell me one thing. 3 by 4 is nearby to 0 or is it nearby to 1? Have you drawn? Just look at your answer. Just look at your notebook and shout it with me. Ma'am, it is nearby 1. Here, it is nearby 1. 3 by 4 lies just next to 1. Understood? Let's move further. Now it's time to represent 5 by 4. Is it a proper fraction? No, it's not a proper fraction because numerator is greater than the denominator. Yes, this is not the proper way to represent a fraction. Out of total parts, we have to take parts take now. How 5 parts? How could I take 5 parts out of 4 parts? It's the improper way. That's the trick that you can remember which one is proper fraction, which one is improper fraction. Now it is improper fraction. So how do you do that? Just divide 5 by 4 and see what answer are you getting. Basically, you try to convert it into a mixed fraction. Just do it your way. Quickly, just do it. Just divide 5 by 4 and just tell me the mixed fraction you got. Just divide it. Yes, it gives us 1 and 1 by 4. Yes, 1 and 1 by 4. How? Should I show you? 5 divided by 4. Mixed fraction is 1 and 1 by 4. Yes, you have got the mixed fraction. Now, 1 is complete in itself. From 0 to 1, we have taken as completely. Now it's time to locate that remaining 1 by 4. Yes? So from 0 to 1, it's taken completely because our answer was 1 and 1 by 4. From 0 to 1, 1 is taken completely. From 1 and 2, I have to divide it into 4 parts because the denominator is again 4. So how are you going to divide it? 1 by 4, 2 by 4, 3 by 4, and 4 by 4. But here we have taken 1 already. So its 1 by 4 will automatically be 5 by 4 because 1 we have already taken. So 1 by 4 is your 1 by 4 and 1 is here. After adding, you are getting 5 by 4. So you have located it. Yes? Just note it down. Firstly, you have to change it into mixed fractions. Then you would be getting two things. One as whole and other one is in proper fraction. Now it's very easy to locate proper fraction. 1 is taken 1 from 0 to 1, 1 is taken. Now from 1 and 2, the proper fraction 1 by 4, just divide it into 4 parts and pick it up the first part because it was 1 by 4. Now just join it. 1 this side, 1 by 4 this side, as whole is giving you 5 by 4. Yes, how to represent it? Let me just clear it to make it more clearly visible. Now, please note it down, not this number line. That's how you would be showing, representing the improper ones also. Written? Nice. Now, representing negative rational numbers. We have done proper, we have done improper. Now it's time to represent the negative rational numbers. So simply negative, where negative lie? To the left side of 0. Here, example, minus 2 by 3. Forget the minus. Is it a proper fraction? Yes, ma'am, it is a proper fraction. Where it should lie? From 0 to 1. But it is in minus sign. Just took it from 0 to minus 1. Yes, so it would lie to the left of 0. Here, from 0 to minus 1. Now, how many parts you are going to divide it into? The denominator is 3. So, 3 parts. 1 by 3, but minus 1 by 3. 2 by 3, but minus 2 by 3. This is 3 by 3 minus 3 by 3, giving you minus 1. So you have located minus 2 by 3. In the same way, it was just a difference of negative sign. The only difference was you were locating to the right side of 0 previously. Now, in case of negative numbers, you have to divide it. You have to represent it to the left of the 0. Right? So, what mistake you have to be alert on? Don't count backward on positive sides. Yes, positive sides, you have to keep on going to the right hand side. But in negative numbers, you have to keep on going left side. This is the common mistake. Sometimes while representing negative numbers, we can go to the right side in a hurry. Always move left of 0 for negatives. Make divisions equally spaced. Yes, could you remember it? We have to move to the left side in case of negative numbers. We have to move to the right side in case of positive numbers. So how do you represent the fractions, the rational numbers with different denominators? So far, what I have taught you that whatever the denominator is, my dear students, you have to divide the segment into same parts. But what if the denominator is multiple? Yes, we are having a couple of denominators over here. So how do you do that? Ma'am, we have to make the denominators equal firstly. Then we'll be having only one denominator. Then we'll go the same way. So how are you going to make the denominator equal? Think. By taking LCM. Well, yes, you are right. We have to take the LCM. So LCM of 1 by 2, 2 by 3, 3 by 4. The denominators are 2, 3 and 4. What would be the LCM? Just find its LCM. Then we'll take it carry forward. Just find it LCM. I'm giving you 30 seconds. You are in 9th grade. You should be pro at finding LCM, isn't it? Just find and let me know what is the LCM. Exactly. Your LCM is 12. So you have to make fractions now to 12. 1 by 2. You have to multiply it by 6 to both sides, numerator and denominator. 6 by 12. Similarly, 2 by 3. How are you going to get 12? 3 fours are 12. 2 by 3 multiplied and divided by 4. Let me show by 1. 2 by 3. We need to get 12 over here. How are you going to do? 3 fours are 12. We have to divide and multiply it by 4. 4 twos are 8 and 3 fours are 12. Yes, 8 by 12. Similarly, you can do for 3 by 4. You are getting these fractions with equal denominator. 6 by 12, 8 by 12, 9 by 12. Just note this down, this example, and just try to find their LCMs and try to make it equal further. Sure? Here, now you have to represent them. You have found 6 by 12, 8 by 12, 9 by 12. All are proper fractions. Yes, all are proper fractions. Numerator is lesser than the denominator. Now mark 0 and 1 here. You will be finding, and how many parts you are going to divide it into? 12 again. So first one is 1 by 12, 2 by 12, 3 by 12. Keep on going. As much fractions you have, as much rational numbers you have, you can represent easily. Well, you can do it. Yes. So that was the concept for today, how to represent rational numbers on the number line. We have done it thoroughly. I wish you have learned it so. Now, please, it's time to go to activity part. Let's put it into an action. Are you ready, my dear students? Yes. Drink water, then we can start. Exciting? Yes, activity seems exciting always. So first example is to plot positive rational numbers on a number line. We move toward the blank of 0 on the number line. Just read it out and tell me your answer. Positive rational numbers. Positive means to the right of 0. You are very right. The answer is right. Now it comes to the example second. Mark 7 by 8 and minus 5 by 8 on the number line. Just open your notebooks again. Maths is all about practicing. Just open it. Both are proper fractions. Take 0 here, 1 here. Always in case of proper fraction, they must lie between 0 and 1. Just draw 0 and 1. A horizontal line is there. Now mark. Firstly, you have to divide it into. How many parts? Just divide it. Divide it quickly. Exactly, the denominator is 8. You are going to divide it into 8 parts. Just mark the 8 segments right now. 1, 2, 3, 4, 5, 6, 7, and 8th part is itself will be 1 itself will be the 8th part. So in between there are 7 parts. 8th part we are considering the 1. Done with it? Now just mark 7 by 8. Easy? But we have to show minus 5 by 8 too. How are you going to do that? Minus 5 by 8, just ignore the negative sign as of now. You are having a proper fraction again, but only the difference is we have to move to the left side of the number line. From 0 to minus 1. How many parts? 8 parts again, right? Just mark it. Mark it 8 parts again to the left of 0. Marked. Now pick your minus 5 by 8. 0. Next one will be minus 1 by 8. Next will be minus 2 by 8. Next will be minus 3 by 8. Next will be minus 4 by 8. And hence minus 5 by 8. Well done. Done? Let's move it to the next one. Represent 11 by 6. It's an activity time. Only you are going to do that. I'm here to guide you and you can help your amazing teacher present there. Just 11 by 6 means what? Improper fraction? Yes, improper one. So just divide it into and get it into mixed fraction. Divide and get it into mixed fraction. You are very smart. You are looking here, I know. But you have to divide it. Yes? Your answer is 1 and 5 by 6. Okay? So from 0 to 1, we are taking the 1 as whole. Now it's time to locate remaining 5 by 6. And we know it is a proper fraction. Divide from 1 and 2 into 6 parts and pick it up. The 5 by 6th part is there. In total, whenever you are taking it as whole from 1 to 5 by 6, you would be getting your 11 by 6. Just do it. I'm not moving forward. Just do it. You have to do it. You have to show it on the number line. That's practice. Yes? Okay, fine. You have done it. On a number line from minus 2 to 2, mark and label. Okay, we'll come this here in a bit. I'll just give you this activity. in a while. Just wait for some time. Because it was the time-taking one. So here, let me tell you which one is greater and which one is smaller on the number line. Just by looking on the number line, you must tell which one is greater, which one is smaller. Here, minus 3 by 4 or minus 1 by 2. You have to draw it. You have to draw it. Just draw a number line quickly again. Minus 3 by 4 lies between minus 1 to 0, means towards the left of 0. Take 0, take minus 1 here and mark 4 points. Minus 1 by 4, minus 2 by 4 towards left, and minus 3 by 4. Yes, similarly, minus 1 by 2 you can have. And what are you observing? Yes, more left means smaller value. Just note it down. Note it down, highlight it. Take a note of it. More left, the smaller value. Yes, in a similar way, the more right, the larger value. It will help you remember and figure out the greatest and smaller numbers. Easy? 3 by 4 is closer to 1 than 2 by 5. Is it true or false? I have marked it true. But you have to justify it by drawing the number line. You don't have to just tell me, ma'am, it's right, ma'am, it's smaller, ma'am, it's greater. No, I want an evidence. You have to justify your answer by drawing the number line. The next question is, minus 5 by 4 is between minus 1 and 0. Ignore the minus 1. Just tell me, 5 by 4 is proper or improper? Improper? So how it could lie between 0 and minus 1? No? Yes. So it won't lie between 0 and minus 1, as minus 5 by 4 is much lesser than minus 1. So it would lie where? To the left of minus 1, you have to see where. Let's try together, represent these numbers on the number line. Let's do an activity now. Let's just focus on my words. Are you ready? Are you ready? Just take your pencil and take a new page. Yes, taken. Note this question. Note this question right now. Create a number line from minus 2 to plus 2. Minus 2, then minus 1 comes, then 0 comes, then positive 1 comes, then positive 2 comes. Just draw a number line and you have to represent these rational numbers. Label each carefully. This is your task right now. I'm just giving you 8 to 10 minutes for that. And you have to do it by yourself. And you can take the help of your amazing teacher present there if needed. But you have to do in order to get perfect in representing rational numbers. So what we have learned, just let me recall it. Rational numbers what? P by Q form. We have to locate them by dividing it into the parts. Negative side we have learned. Mixed fraction one, improper one we have done. So this is your question. This will wrap it up this session and you will get pro at representing rational numbers. Thank you so much, my number explorers. Just do this question. This is not dispersal time. This is activity time.